Okay, guys. Yeah, I know we want to eat. I know we are tired, but we need to deal with it. Okay, so we have 20 minutes, and now we need the questions to come out. So I will go with one that is not super suitable for this workshop, but still makes sense, um, which you cannot respond. Yeah. So, which is your favorite neuromorphic computing platform and why? Come on. Yeah, thank you.
First. Again, I try to tickle someone. It's a microcontroller because in my microcontroller, I have the sweet spot of energy consumption and flexibility that is well suited to many real world problems. Very often, I fully understand there are some problems that need microwatts. I fully understand there are many problems that want a computer center of terawatts or so to process giant networks. Most of the robotic problems have an energy budget somewhere between 50 milliwatts and 500 milliwatts. And that's exactly what I can do with the system, with the microcontroller. And these are so efficient today that I can run I get much bang for the buck.
Yeah.
I totally disagree.
Very good.
That's why I asked this question.
So I think actually that we don't need neuromorphic for the low-level tasks because the microcontroller is also good with PID. You can easily run on the microcontroller, right? So I think we need it for the bigger networks like the vision and not as big as they do in computer vision, not ChatGPT.
They can articulate you.
But yeah, we need it for the larger networks, and that's why yeah, I mean, I think the ideal chip doesn't exist yet. I think spec is on a really good track, but yeah, so yeah.
Then, but can I add then, unless you want to, guys, you cannot, but you want to, guys, add something on top of it.
No, so in my research, I don't use neuromorphic platform that
But
much.
why?
No, just because it didn't happen to me to. So of course I explored. I know just let's say theoretically what neuromorphic platforms are. I know what I would like from neuromorphic platforms. So maybe I know that they are very expensive. So also the cost I think is a parameter now to select for people. That's why maybe we use CPU instead of neuromorphic platform, even if they have many advantages. So I'm very interested in spec probably because for my application there is like this direct connection from processing to from the event camera to the processor without gaps. So probably spec, just naively.
And now Suman is going to say spec.
Yeah, sorry to disappoint, but yeah, I think it's gonna be a repetitive answer here as well.
Yeah.
I also feel like for me, the promise of neuromorphic computing is about embodiment and learning directly from sensing data to control data. And the fact that spec has this direct connection from the sensor to like the processor is and doesn't have to go through a USB or a serial bus, really is going in the right direction. So I also don't work a lot with neuromorphic hardware, but I think learning the theoretical principles is the direction that is most promising to me.
Yeah, I want to add another thing that possibly is key to adaptability, right? Like because if you need to have lots of timescales, right? Like little timescales, and you need to interact with the environment, then you can't do it with a classical ANN. So that's the question that I wanted to add when you responded before.
Adaptability, I'm not sure if an SNN would be better than an ANN, but
I bet yes, because we can handle more timescales better.
Yeah, perhaps. So one last thing on the previous question is that I also disagree, and we agree on many things. But where I also disagree is that I don't think we should first figure it out, and then I think there should be an interaction between chip makers, and then we try things out, and we notice the limitations, and we tell them, and then of course they make choices like whatever they think is best. But I think the chip makers and the algorithm makers, there should be an interaction,
and already we agree again. So I completely agree, but let me rephrase my statement.
Okay.
I think the chip makers are ahead of what the algorithm makers can do today. Probably the chip makers disagree, but then again, people in computational neuroscience, they think, oh, we need to know more details about neurons and we need to go deeper and deeper and deeper. I think we don't. So I think every community wants to go deeper in their knowledge and their base. But I think that there are more efficient chips available, even though they're hard to get hold of, but these chips exist, compared to efficient algorithms, smart algorithms. So I think we need to push the algorithm people more.
Is there any other question? Yeah.
I put this question about, in your opinion, what's the most important problem in terms of application that we cannot solve using traditional systems, and the only solution would be in
So the question was, what's the most pressing problem?
I'm gonna repeat it. What's the most important problem, or like give me the problem that you cannot solve with the classical RGB cameras, and like you should or must solve it with image-based cameras.
Not all at the same time.
So guys, I have my respect. I'm not here as a speaker.
Yeah, okay. I'm not sure that's the right question to start with, but yeah, no, I know, but I mean, well, so I'm not sure that's the right question in the sense like, I mean, I would answer, of course, like, yeah, with the RGB camera setup, I would not be able to make the tiny drone autonomous. Yeah, because it's, so that's one answer. If you really think like a vision person, I mean, it would have to be about really low latency things, like the advantages that you have. And I think, you know, of course, you can go low latency with like a really fast global shutter, but it's like, it's going to be, you know, the lighting and it's going to be energy intensive. So yeah, I think it has to do with the robotic aspects of it. So energy efficiency and low latency. So in the racing, we hope we can be, we're already super quick with a rolling shutter camera or an NX, right? We fly 100 kilometers an hour, we beat these human world champions. But I hope that with event camps and spiking that neuromorphic processing, we can be even quicker. But I don't know what the delta is going to be, right? We're not going to go 300 kilometers an hour. So, yeah. So,
you think my question is like, what is one application that you really want to solve and you really need it, how we cannot do it? Because like, I mean, your experiments are pretty cool. I really love your work. And I agree that even cameras are just a way to improve. But in terms of all the problems that we can solve in robotics and computer vision, like, it's not my priority to solve that thing first, you know?
Did you all hear it? Was fun? But...
Yeah.
No, I don't know the answer. I kind of ignore your because I was about to say that we should pose the first question differently. It's not what is the problem that we can solve that nobody else can solve, but it is the question of what application is there that neuromorphic can solve or address so much better that people are willing to investigate. It's slightly different tune on it. And I think there are some, what I try to express, there are some niche areas where the product of available power budget and acceptable latency is such that neuromorphic and event cameras can solve it. There's Guido with the drones. There is something that is always on observation, where you might have, Toby talked a lot about this, where you might have toys, kids' toys, where you have a vision sensor observing, is somebody interacting with me, yes or no? That's a problem that a neuromorphic sensor plus an always-on neuromorphic processor can solve. Or having sensors that are supposed to survive out in the wild forever. You build a small sensor package that is more than an on-off switch. It's not just a trap for wildlife animals. It's something that detects, is it an animal or a human-made object, or is it a human? And does this mid amount of processing for many months or with the solar cell forever. There might be limitations out in space. Satellites have very limited power budgets and would like to do this always on monitoring. There's very sparse events happening. So there are application domains that people have identified and then discuss and work on. But we all know there is no killer application out today.
Yeah, I agree with Jörg. So because we are used to be taught that even cameras are really good for fast, like dynamic, very dynamic, high speed tasks. So for example, if you, I don't know, a robot has to catch a flying object, for example, you can reconstruct and you can have like track with very high temporal resolution the object. But someone can claim that you can do with a very high frame rate camera. So in this way, is it true that high frame rate camera and even cameras can do the same for this kind of job, but they can't do the same job at the same power consumption? So probably all the application where the robot is remote, as Jörg was saying, where you don't have like power budget available. But I was thinking also like augmented reality, where, for example, you need to do the processing and all the computation on board, and you don't want to depend on like external batteries or something that is uncomfortable and not user friendly. That increases the weight of the system. But probably the most easy application, in my opinion, also when we had to like collaborate with the company in the industries, it's really difficult to prove that even cameras are worth. So probably, yeah, the drone application is one of the most understandable by them, in my opinion.
Expert.
Yeah, probably I will have a very different answer. As everybody else mentioned, if you're ready to consume orders of magnitude more power, yes, you can do almost everything. But there are actually some distinct applications that Guido that I don't know if you were there in the event-based Slam session workshop on Monday. Our CEO, he had some nice slides showing one distinct example is lightning detection. So the lightning strike is something very fast and you need an always on system for preventive reasons, maintenance reasons, to turn off, for example, some systems if it's not lightning is happening, and you need to detect it really early, and you need to have an always on system. So we have a very successful implementation of this, and this is what I can do. From the examples that today I had in my talk, I believe the optical tactile sensing, the event-based one, the sleep detection, the early sleep detection, there is also something that RGB cameras, RGB-based tactile sensing cameras systems cannot do, or if they are able, it would be with a huge orders of magnitude higher power cost.
Yeah, maybe just to add something to that, like all of these applications are like focusing quite a bit on power budgets and latency budgets, but also I think like the fact that event cameras record transients instead of just like static signal allows us to do like some interesting interactive tasks, like understanding physical properties of objects in robotics. Probably it was similar to the lines of visual tactile sensing, where we could try to like use transient signals to understand our form of knowledge, like our knowledge of the world model, or about interaction mostly with the world. So I think that's another application that would be like really useful.
Okay, do we have any? Yes.
Try to speak in the
I just want to know your opinion about the trend of increasing the resolution of an event camera, and if that is indeed, sorry, there was a whole paper about it, but indeed, on the first workshop of Monday, I just saw that there is a new event camera that has even a higher resolution, and we have a lot of data, and especially when the environment is quite dynamic or the camera is moving. How are we gonna process all that? We can use brute force, we can change the representation, give it to a GPU, and that's all. But even though transmitting those data to the cable, putting inside the computer, moving into the GPU, that is not that fast. So, is that necessary? What are your insights?
I love it. Thank you for asking this. Yeah, please.
So of course I have an opinion, because we discuss this a lot also in the lab with colleagues, people discuss it. I think it's a complete waste of resources for robotics. There might be other areas where higher resolution is needed, is critical. For example, if you want to do large field observation and long distances, but that's a very special computer vision challenge. If you want to do robotics, you look at animals. I mean, flies have 60 by 60 ommatidia or so, that they can do amazing things, as Guido witnessed today. You must have seen a lot of flies in your life, but I don't. They're very good. I really don't think we need higher resolution for the typical robotics tasks, meaning doing navigation, identifying object distances, and so on. We should much rather use the very high spatio-temporal resolution and make use of that.
Would like to add that, like, so insects indeed have lower resolution than like the ommatidia.
Yeah.
Depends on the animal, of course. So dragonflies a bit more, but what they mostly have is a very wide field of view. So as someone working on like robotics, like the drones, I would prefer them to go in the direction like how can we actually see in a wider field of view with a really small sensor and not necessarily much more resolution indeed.
Yeah, I think for me, like maybe for robotics, as Guido and Jörg said, it doesn't make so much sense to keep increasing the spatial resolution. Maybe for computational photography or tasks like this, you get like much better benefits when you have offline processing. But I also think like you can kind of use the high temporal resolution to kind of infer spatial resolution as well. You can use the fact that events occur really close together in time to kind of somehow predict the motion field and do some kind of super resolution for tasks like that. So you can kind of use one against the other. I think Daniel Gehrig from Davides Conferences had some work based on this as well.
You want?
Yeah, I just agree. I think, yeah. No, I mean, for robotics, I'm not needed that higher special resolution.
You want to add anything?
Yeah, I would just add that, yeah, I can see this trend that based on the domain and application, different requirements are emerging and does not necessarily mean that it is targeted for robotic, for instance, for mobile devices, for XR, VR applications, for autonomous driving. Each of them have different requirements, and those needs to be, the resources needs to be aligned with that for processing or compressing or depending on application.
Yeah, I just want to add one small thing because this is exactly my research field. So when you have a small visual field, you're required to move, right? Exploration means active sensing. That's difficult, and not so many people want to deal with that. So that's another reference. Any other? Yes.
Let me ask opening questions that the vision system has developed several decades away from CCD to CIS, the most interesting sensor, we call it RGB, to the event camera. So do you think the event camera is the final or the future vision solutions? And I want to know your opinion.
Did you guys hear it? He wants to know what would be the future if this is the final round. No, it's just the first one. Let me just please go.
What do you mean? What do you mean by final? Like the most promising
I mean that
technology.
The event camera is really in that now we can say that the event camera has a lot of advantages. It may be the best vision sensors, but maybe in the future, what is the next neuromotic vision will become? We know that event camera is a very famous milestone for neuromotic visions. So what is the next milestone?
Probably also like the I think a hybrid also is really good, like a frame-based cameras coupled with event-based cameras, because there are some like good advantages in one word and in the other that are like not they are complementary in some way. So maybe some hybrid system. But also I know that for robotics, even camera are really difficult, and still people prefer to go for like LiDAR because for example, the lighting condition, it's a good thing about even cameras, but like also LiDAR works really well under bad illumination conditions. So probably, yeah, it could also at some point die or be integrated with the other good sensors.
Yeah, I have maybe two different answers to this question. The first is, I think active sensing or active perception is probably like one way to go, as Julia mentioned, like doing some sort of foveated vision or some sort of foveated rendering where you limit the number of pixels, but you have some sort of control loop within the sensing in order to like have a unit that works somewhat like the mammalian eye. And the second thing I would like to say from a vision point of view is that like event cameras are like a subset of measuring photons. So I think the more in the future, like going closer and closer towards single photon detection at a very high temporal resolution with very high signal to noise ratio, like maybe like single photon avalanche diode sensors. These are probably like much higher like it samples the photons much better. So maybe like that is one direction to go to. So there was, I think, this paper, I think this year or last year about like the generalized event camera where they at CVPR, I think, where they talked about how you can abstract different levels of event camera from the single photon sensors. So I think those are.
I can add one thing. So discussing with PhD candidates in our lab, Yu and Wu, yeah, we're also thinking like, yeah, events, like, yeah, it's on, off, and sometimes you get lots of data. And if you look at indeed human vision and the information traveling between your eyes and the brain, it's probably richer, but more compressed. So we're definitely still missing something, probably. And some people want to combine indeed RGB events. Yeah, I would love to find out like what is actually the compression that we are doing and what would be optimal for robots and what would it mean on the hardware level. So I think there's still indeed improvements possible.
Okay, so I'm gonna add one thing that hasn't been added. So there's not so much change from mission on. The cameras are still kind of the same, right? So, and I'm talking about 80s, right? So actually there is lots of work that we could do at the sensor level. This means taking inspiration, for example, yeah, someone is doing it, taking inspiration from the retina layers, because we could output motion information, speed information, we could output the speed direction information, an easy SEMD, spiking elementary motion detector. So we could add way more meaningful events directly out of the sensor. There are some people at the Maryland that are doing it. I am doing it through software based, but this is a proof of concept to the new possible cameras, event based cameras in the future. So this is really just a start, in my opinion.